Okay, so what I'd like us to focus on today is just navigating which test or confidence interval we should use in a particular instance, because at this point it feels like they've accumulated quickly, but there's 6 to 8 different tools that we have depending on what we're trying to measure or what we're trying to estimate. So if you go to our Unified Classroom class page, find that button that says Inference Review. I want you to click on that. And if you work through this on your own, you'll get maybe different questions than what I have selected here, and that's okay. But the button I want you to try is this which test interval. It may require that you download a Java applet, so that's a possibility. Just make sure you do that. Now, let me just speed through which ones that you're going to want to highlight, okay, or check off. So, confidence interval for population mean, that was chapter 9, or chapter 8 rather. So that's a T interval, right? On the calculator, this first one would read T interval. Confidence interval for a population proportion, that is our 1 proportion Z interval, right? Notice we never do Z interval, just like we never do Z test. If Z is involved, it should be a proportion that we're measuring. Confidence interval for difference between two independent, I think that is means. It goes on to say, you'll see it bigger. So if it's 2 independent means, that's the 2 sample T test, or 2 sample T interval rather. These are still intervals. So that'd be your 2 sample T interval. We didn't see those till chapter 10. This is also still a T interval. This is where we have a matched pair setting. So we subtract the numbers in the list because they're not independent of each other. Each pair is connected, so we find the differences, and then we're t-testing or making a t-interval of the differences. So this would, on your calculator, just be a t-interval. Confidence interval for difference between, so this is your 2 sample. If it's proportions, it's a 2 proportion z interval. If it's means, it's a 2 sample t interval. Okay, and then we skip the intervals for linear regression. Not something that we're really focused on in this course. And then we move on to our hypothesis test group here. So there's 4 of each, 4 different confidence intervals that we might create. Again, the t interval, the paired difference, is really the same as this thing on the calculator, except you'd have a third. You have to make a third list. It's only one list, but you have to create that list. So it's a subtle difference, but the way it's executed on the calculator would be the same. But if we were trying to set it up, we would differentiate between whether it's matched pairs because it's 2 different groups. And then same thing with our hypothesis test. Chi-squared, we'll save that for chapter 11. So let's give it a shot. All right, so how much more likely is it that a pine nut planted in fertilized soil will germinate compared to pine nuts in nature? Biologists know that 12% of all pine nuts in nature will germinate. 55 pine nuts were planted in fertilized soil. So I do have a population parameter here, it's 12%, so I know I'm dealing with a proportion, not a mean. But when I read the language here and it says how much more likely, there's not really a claimed value there. So I'm definitely trying to estimate something, all right? And the estimate would be the difference between my p-hat that I get here and then this 12% parameter number. So we don't have to set up and run the test, but I can tell just by reading that this is going to be a confidence interval for a proportion, right? And I'll compare it to that. And when I get it right, I get the smiley face, and everything's good with the world. Okay. Next one. You're interested in estimating the average number of hamburgers. So right away, now I know this is something to do with the t-distribution. Okay. And again, we're estimating, right? Number of hamburgers Americans eat each month. You survey 200 Americans. So when we survey these Americans, we're going to say, how many hamburgers did you eat this month, right? Then I'm going to take all those 200 answers and I'm going to average them. So I'm going to have an X bar. And I'm trying to estimate this. There's no tested claim against this. So this is just, it's one sample of 200. And it's a confidence interval for a mean. So on your calculator, it would be a t interval. Okay? And we get our smiley face. I'll walk you through a couple more. And then I'll let you try some of these on your own. How much does personal spending increase after a tax cut? 1,500 people were studied before and after the tax cut. Okay, so now we're going to have a before and after situation. This sounds like a matched pair situation. All right, so I'm going to ask people about their personal spending, and I get that number, and everybody has their own number. And then after the tax cut goes into effect, I'm going to ask everybody the same question again. I'm going to look at the differences. So this is a matched pair setting. These two samples are not independent of each other. And I'll find a matched pairs difference and compare them. So 1,500 were studied before and after. So it sounds like, and it says how much does it increase, right? So it sounds like I want a confidence interval, right? Confidence interval for paired data, okay? And it's not a difference in proportions, okay? All right, so the next one, I want you to give it a shot on your own. Let's see how we do. So you want to estimate the average number of pine cones that a 30-year-old pine tree produces each year and state the margin of error. So if we pick the right answer here, the confidence interval for population mean. Okay, let's try another one. Do students learn better in groups than alone? Study was done where the students worked in groups to study for the first midterm, but worked alone for the second midterm. Okay, so assuming we have each student's grade when they worked in groups and when they worked afterwards, we ought to be able to do a t-test to see if one is better than the other. So paired data dependent samples would be the right choice for that one. Are skiers more likely than snowboarders to fall? 50 skiers, 50 snowboarders were observed as they went down the run. So I have more likely indicates a proportion. Right? Two different proportions, two independent. The skiers and snowboarders are not connected with each other. And I specifically want to see if one is more likely than the other. So this would be a hypothesis test for the difference between population proportions, right? How likely something's happening. Okay, so that's good use of that. Now what I wanted to jump to next is our first learning objective. So you'll notice when we get to, and not sure how everybody does the learning objectives, maybe you do them differently, but you'll notice here, this is going to go back to 8, 9, and 10. We're going to look at each of these and we're going to do exactly what we just did on that applet. Okay, we go through systematically. So I think the best way to do this is to write down your answers first, and then you can come down here and click on the show your answer button and see how you did. Okay, so do people smoke less when cigarettes cost more? So they took a random sample of 500 smokers. The number of cigarettes each person smoked was recorded before a 30% cigarette tax was imposed, and again for 1 month after the tax was imposed. So it looks like we have the same 500 people both times, so this would be a matched pair setting. So we would find the number of cigarettes a person smoked before and after, and we can calculate the pair difference mean for that one, right? So it sounds like it would be a matched pairs, and it would be a t-test, right? Because it says do people smoke less when cigarettes cost more. So we do want to have a direction to that. We're not just estimating how much more do people smoke, right? If we were trying to estimate that, we want an interval. So this is going to be definitely a t-test, but it would be a matched pair setting. Part B, how much greater is the percent of senior citizens who attend a play at least once per year than the percent of people in their 20s, right? So we have two different populations, right? We'll get a proportion from this group, proportion from this group, and we compare the two of them, and it says how much greater. So I'm trying to estimate something here that sounds like it's going to be a confidence interval, right? So that would be a 2 proportion z interval on the calculator. If you want to use the TI language, if that makes the most sense to you, that's okay. So that's kind of what I'm doing here. This one would have been a t-test, right? But it's a matched pairs specifically. This would be the 2 proportion z interval, okay? And now here we have 16 locations in the Adirondacks. We want to estimate the average acidity of rainwater. So we're estimating, so it's definitely a confidence interval, and it's an average. So we always use T for means. So this is just going to be, on the calculator, it's just going to be the T interval, right? It's a one sample T interval, and we'll get our estimate. Even though they're giving me these numbers in here, 0 to 14 and 7, it's not really giving us anything that we're trying to compare to. So I think a T interval will work there. Consumers Union wants to see which of two brands of calculator is easier to use. They recruit 100 volunteers and randomly assign them to two equally sized groups. People in one group use calculator A, and those in the other group calculator B. So I don't have these 100 volunteers using both calculators, right? 50 are using A, 50 are using B. So and they calculate the time required for each to carry out a task. So it's going to be an average. It's not a proportion of success or fail, but it's how much time on average did it take them to complete these tasks. So this looks like it would be a two-sample t-test, right? Record times required for each volunteer to carry out the same series of routine calculations on the assigned calculator. So this sounds like it could be done as a match pairs, but the way I'm reading this is set up sounds like it's a two-sample t-test. Okay, and then we can click show your answer. I'm sorry, two-sample t-interval, right? Because we're trying to estimate. We don't know which one's faster than the other. And then you can check down here and see the correct answers. Right? Okay, so if you have any questions on the learning objectives as you're working through them, we'll post them to the discussion section, but I will try to check in daily and do at least another one or two learning objectives throughout the week.